Good afternoon, everyone. This is your speaker, Sebastian. The topic for presentation today is a vertical approach for beyond 5G mobile networks. Before I go into the slides, I will share about myself. I'm a 3GPP delegate that joins standard meeting frequently since 2017. I'm also an implementation track Ph.D. student from NCTU CS department. So, my talk today is related to 5G core network implementations. We got to know the mobile system before we go into the talk. The most familiar mobile system should be the 4G mobile system. I believe that everyone has a mobile phone. You might also know the base station, which we will call it Radio Access Network, RAN, ENO-B for 4G base station, or GNO-B for 5G base station later. But people might not know about the core network that hosts within operator site like Chunghwa Telecom. From this figure, we can see that the 4G mobile system components like the UE, which is a mobile phone, the Eutron present as a base station, the Evolve Packet Core present as 4G core network, and server PDN, which means that the Internet Gateway or Service Gateway. The Universal Integrated Circuit Card, also called SIM card, which you need to put into the mobile phone in order to connect to the subscribing operator site for mobile service. Since I will talk about the implementation for core network, I will share the overview of 4G core network architecture to you. Informal mobile system includes 5 basic entities to serve the subscribers. The MME, the Mobility Management Entity, handles registration, mobility access, and session creation. The SGW, the Serving Gateway, handles data plan receiving and forwarding to a Packet Data Network Gateway that we so-call PDN Gateway. The PDN Gateway to forward the data plan to the Internet. The HSS, the Home Subscriber Server that stores subscriber information for subscriber authentication. Lastly, the PCRF, the Policy and Charging Rules function to handle data plan charging. After the background introduction, I will continue my presentation today. This is the outline. First, I will go through the introduction about 5G, including my motivations, and next, I will go through the issue study, and next, I will share about the future works, and then that's my conclusion. So let's get into the introduction. In 5G mobile networks, we have several commercial models. The most common model is Public LAN Mobile Network, the PLMN, that provided by operators. There are 2 other models for enterprise network. Enterprise can ask operator to help and host the enterprise mobile network under PLMN. Enterprise can also host the mobile network themselves. And we will focus the talk on isolated enterprise mobile network, which the enterprise hosts the private mobile networks themselves. So what we can do with the isolated enterprise mobile network. Enterprise with software 5G core network can fully manage their mobile network themselves. Vertical applications such as connected car or AI factory can share within the network proprietarily. Big enterprise like TSMC with headquarters and branches can connect to each other using the isolated enterprise network. With isolated enterprise mobile network, the data are safe because the data will not share with the public. Here, we show an overview of 5G core network architecture. In this figure, we show the network functions within the 5G core networks. AMF is a network function handles subscriber registration and mobility. The AUSF for subscriber authentication. The DN is the Internet. It's not part of a network function. NRF for network function to look up other network function API locations. PCF that handles subscriber policy and data charging feature. The SMF for session creation and deletion. The UDN is a transaction control to access UDR. And UDR to store subscriber information. UPF that handle and forwarding the data plan from UE to DN. RAN is the base station for 5G. So each of the network functions except RAN and UPF are connecting using service-based interface that running with open API on HTTP2. In this figure, we will show the relationship of network function within 5G core networks. And for the numbers of the interface that we will explain in the next page. This table shows the details of reference point. N1 is the reference point between the UE and AMF. N2 is the reference point between the RAN and the AMF. N3 is the reference point between the RAN and the UPF. N4 is the reference point between the SMF and UPF. N6 is the reference point between the UPF and DN. N9 is the reference point between two UPF. N11 is the reference point between the AMF and SMF. N16 is the reference point between two SMF. N16A is the reference point between SMF and ISMF. ISMF means that the intermediate SMF. N38 is the reference point between the ISMF. And this is the response point that we will use it later. In this page, I will show my motivation on research the isolated enterprise mobile network. Assuming that we can apply the vertical application on the PLMN for public user, we have found that this is difficult to serve the dedicated vertical application because the application data is not isolated. In other words, it says that the data is not safe or can be shared in the public. Also, isolated enterprise mobile network. If let's say we are deploying the multiple control plane functions within the enterprise, we have found that this is a wasting of a resource. It is lucky to say that the 5G core networks designed in cloud native. The control plane, they are using the network function virtualization idea, so the network function can be deployed dynamically. User plane, they are using the software-defined networks idea, so the control plane and user plane are decoupled. If we have the scenario that's a central and branches office, so the core network can be deployed the control plane or in headquarters and put a user plane to the branches office. So our purpose is to implement a vertical application-based 5G core network. Next, we will go through the issue study. We make an assumption scenario happens to central and branches enterprise network. We can deploy the core network to the central site, and also we can deploy the core network to the branches site. But we have found that this design maybe is a waste of resources because we have duplicate core network. If you want to save the resources, we can just only pull part of a core network like SMF and also UPF to the branches network. That we have found that the SMF in the branches network need to communicate with the central network. But this happens to that the UPF in the branches network need to listen to the branches SMF networks or the SMF from the central network. The other easier way is to pull out the UPF from the core network, so we can deploy the UPF to the branches network only, and all the commands are listening from the central network. Among these three designs, they have their own pros and cons, and we will talk about it later. Some other scenarios such as AI industrial IoT and vehicle to anything can use the private mobile network. The AI industrial IoT can change all the service procedure to make sure the faulty rate is low. For V2X, we got to make sure the vehicle on the route are driving safe. The vehicles can group their network together if they are connected to a private mobile network. So no other interfere command sent to connected car. In this page, we'll discuss the pros and cons in central and branches office. How many network functions shall deploy in branches network? If let's say we deploy too many of the network function, they will find that this is a resource wasted, and the management will be very complicated, and the procedure will be very redundant. If let's say too less, this is a strong dependency on the central networks. We have found that we need to communicate all things with the central network. Like we want to build out a PDU session, we have found that the latency will increase. Again, if let's say we deploy multiple SMF, like we have one SMF in central and one SMF in branch, then we have found that the UPF has a difficulty to listen to the SMF. If let's say we put the SMF in the local site in branches, we will find that the response is very fast, but we don't have a global view. And the SMF in the central, there's a global view, but the response time will be increased. If let's say both we need to put there, and we have found that the packet detection rules to the UPF might conflict. Let's see the example run that UE in central and branches how to communicate. There's a way from a UE from central site to communicate with the branches site via the UPF, and the UE from the branches site with another branch would like to communicate, they can run through this way. And if let's say the UE in the same branch, they don't need to go through the SMF, they can go through the UPF only. And there's another way is UE from one branches to another branches, they need to pass through two UPF. As what we discussed just now, we have a central network and branches network. So what we can do some improvement is on the branches network. If let's say we are going to implement the things via only the UPF, that we have nothing to do, but what we see is about the SMF. If let's say we have SMF in central network and branches network, this might be ambiguous to UPF in branches network. So the UPF in branches network don't know which SMF they should listen. Also, as discussed just now, so we can have the SMF in the central network to control the ISMF in the branches network via the N16A interface. But the things, if let's say we concern about the latency, that the command need to send from a central network to the branches network might be lengthy, so the latency will be long. But we can consider about that if let's say there's an interface between the central AMF and also the branches SMF. This is not covered in the standard, so this might reduce the procedure to have the control from central to branches. Why we need to study that? Because the 5G core network become a software might affect the industrial like operators and also the vendors. If the user is an enterprise roles, they can take some benefit from that. From operators' point of view, if verticals own 5G core themselves, the profit of an operator might drop. If an operator wants to overcome this issue, they should offer service to vertical with a package of subscriptions. From vendor's point of view, the number of orders of the dedicated machine for 5G core may drop, because the vertical can simply buy a commodity equipment to install the 5G core network, and no need to purchase a dedicated machine from Nokia or Ericsson. So the vendor would like to overcome this issue. They can focusing on develop the powerful computation equipment like smart NIC card for performance improvement. So they can install this equipment to the commodity server also. From a user point of view, the vertical sector from industrial act as a private operator, so they can control their network themselves. There are some benefits that a mobile network within an area can be isolated, so the data is not shared, and the data will be very safe. Next, I will share what I will do in the future. In my lab, we have done the open source core network which named Free5GC. This is a standalone 5G core network and is the first open source standalone 5G core network in the world. We will use it to deploy a private network in NCTU. With the consideration on Gnobi is not ready to the market, we have also implemented the non-GPP access feature that allows UE from Wi-Fi access point to connect to the core network. We will implement and deploy the downsized core network to other buildings and do some evaluations. So this implementation and deployment we can make is a prototype for industrial to refer. The industrial can also do their own modification based on their requirement. We will try to minimize the number of procedures between each interface, so the communication between central and branches can be faster. We will also evaluate the data response time between the private data networks, which is from central to branches, the local data network only within the central or branches, and also the public data network that the core network is hosted in operator site. Our ultimate goal is to serve the vertical application with minimum of network functions, so the capital cost and the operation cost for vertical sector will be decreased. Next, I will make my conclusion today. I'm not going to say that this is a conclusion, but this is a contribution to the industrial. So what we do is study and implement the best combination of forming the vertical application mobile networks. So the vertical can refer this design and deploy their own mobile networks. And also minimize the complexity of the core networks. So this is easy for managing the network functions. The vertical can simply just say to do their own management. Minimize the requirement to enter the 5G mobile networks field. So we have done all those complexity part, so we can make this easier to the industrial, so the industrial can grab the things and use it directly. Thank you for your attention. So if let's say you have any questions, please drop down your message to the comment box. Thank you.